Binary, a numbering system where all possible values are represented by two symbols, like on-off, true-false, or 1 and 0. Computers handle all data as a stream of binary numbers, because from a hardware perspective, it's much easier to represent two values with a transistor as opposed to 10 values with that system they taught you in school. It first appeared in ancient Egypt with Horus I fractions, and is used independently in many other cultures, like for the I Ching in China, and is the basis for Morse code, where every letter of the alphabet is represented by two different sounds. When the first computers arrived, they were programmed by manually flicking switches, or with punch cards used to represent binary values. Today, modern microchips use Boolean algebra to combine logic gates, like AND, OR, and NOT, to execute binary code billions of times per second, allowing you to share silly videos with your friends on the internet. A single binary digit is called a bit, which is either a 1 or a 0. You can't do much with a single bit, so they often come in a package of 8 called a byte that can represent 256 different values. Modern programmers don't write binary directly. Instead, we write code in a high-level language like Python or C++, which can then be interpreted or compiled into a binary format. However, you should still know how to count in binary to impress your friends. In the base 10 system, you have 10 different symbols. When you get to the number 10, you add an extra digit, then another one for 100 and 1000 and so on. This is called positional notation, where each position represents a value 10 times greater than the position on its right. Binary works the exact same way, but because we only have two symbols to work with, the position on the left represents a value that is 2 times greater, like 1, 2, 4, 8, 16, 32, 64, and 128 in a byte. To get its corresponding decimal value, we multiply 1 by its place and then add them all together, which in this case would equal 123. In a computer, these binary values are mapped to something more interesting for humans, like a letter of the alphabet in an ASCII table or the color of a pixel in an image. Now, because binary is so hard to read, you'll often find it converted to hexadecimal format, which is a base 16 numbering system, using the symbols 0 through 9 and A through F. Conveniently, each hexadecimal digit can represent 4 bits, which is also called a nibble. A low-level programmer might take a hex dump to analyze the raw data of a file. It's in hexadecimal format, but each pair of characters represents 8 bits or 1 byte. This has been binary in 100 seconds. If you want to see more short videos like this, hit the like button and subscribe. Thanks for watching, and I will see you in the next one.